Welcome students. As promised earlier, we are going to analyze a beam with three moment equation. Let us say this is a continuous beam ABCD with CD portion overhanging. CD portion is loaded with 4 kN per meter. I for CD is 2I. BC portion is having 2 point loads 10 kN and 15 kN acting at 1 meter from both the ends. Okay, the distance of CD is 1.5 meters, and AB portion, AB beam is of 3 meter length, but this 20 kN is acting eccentrically. So this is the most difficult example I have considered. It contains overhanging, it contains a fixed support, this means imaginary support. It also contains the settlement of supports. Support B settles down by 5 mm. You are learning in foundation engineering, soil engineering, that there can be settlement of supports. So support B settles down by 5 mm and support C settles down by 12 mm. Value of E is given 2 into 10 to the power 5 Newton per mm square. This means it is of steel. All of us know in SOM we have seen it is of steel, and cross section of the beam it is given 10 cm width and 15 cm depth. So it is quite heavy section, heavy steel section. 10 cm you can imagine, 10 cm width and 15 cm depth. Quite heavy section, a rectangular cross section of the beam. So we need to analyze using three moment equation. Now my friends, step 1, the first step is find out the equivalent structure. Find out the equivalent structure, because the overhanging portion is there. We need to convert that overhanging portion into equivalent structure. Now let us say this overhanging portion CD, I am drawing it CD. This is 4 kilonewton per meter for 1.5 meter is equal to, now I can convert it into equivalent structure. I will leave CD portion blank and I will convert it into equivalent structure. So I can calculate this is 4 into 1.5, that is 6 kilonewton load is acting at C. Let us say this is C and this is D. Let us say this is C, this is D, C and D. I need to convert everything into C and then leave CD portion, and then 4 into 1.5, that is the load 6 kilonewton acting at a distance of 0.75. Acting at a distance of 0.75. So this is 4 into 1.5 into 0.75, that comes out to be 4.5 kilonewton meter. So the equivalent moment is 4.5 kilonewton meter. So these two structures are equivalent structures. So I got it that I can convert the forces on the portion CD into a single force and single moment acting at C. Now I can draw the equivalent structure like this. I will draw it only for ABC. I will neglect the portion CD. By taking into account what are the effects of these forces. So I am just writing this is equal to 6 kilonewton and this is 4.5 kilonewton. This is C, this is B, this is A, and rest of the things are same. This is 20 kilonewton acting eccentrically, and there are two loads 10 kilonewton and 15 kilonewton acting at these distances 1 meter, 1 meter, 1 meter, 1 meter, 1 meter, 1 meter, and this is 2 meter and 1 meter, 2I, and this is I. My friends, I have converted this given structure, into an equivalent structure by neglecting the portion CD. I want to omit CD and I want to convert the effect of CD into one single force and one single moment. So I have converted the portion CD into one single force acting at C and one single moment acting at C, like this I have converted it. So this is the effect. So these two structures are equivalent. The original structure given and this structure is equivalent. Now I am taking into consideration the settlement of support. Now first ABC is the structure. Now applying three moment equation to spans AB and BC. Applying three moment equation to spans AB and BC. Now AB span I will draw, BC span I will draw. Now my friends, BC span, this 10 kilonewtons and 15 kilonewtons. There is a beauty lying in it. I have purposefully taken these two. Now, while discussing BC span, can I say this BC span, let us discuss AB span later. I know how to draw the bending moment diagram for AB. Okay, I am talking about span BC. I am talking about span BC. This 10 kilonewton and 15 kilonewton acting on BC is considered to be this 10 kilonewton at 1 meter and remaining distance 2 meter plus this 15 kilonewton at 2 meter from B and 1 meter from C. This is called as principle of superposition. This is called as principle of superposition. Principle of superposition. This is called as principle of superposition. BC, two loads acting on B are considered to be addition of individual loads, addition of the effect of individual loads. When number of forces are acting on the structure, then principle of superposition says the total effect is equal to addition of individual effects. The total effect is equal to addition of individual effects. So first of all, I will draw, now I know I will draw for BC portion, this is 10 kilonewton and 15 kilonewton, 10 kilonewton, 15 kilonewton acting at a distance 1 meter, 1 meter, 1 meter. Okay, this is my BC, 1 meter, 1 meter, 1 meter. This is my portion BC. I know it is equivalent to a portion which is 10 kilonewton. This is B, this is C, and I know it is equivalent to this is 1 meter and remaining is 2 meter plus same portion, this is 15 kilonewton which is acting same, this is B and this is C. This is principle of superposition. This is 2 meters and this is 1 meter. Now can I plot the bending moment diagram for this? Yes, I can plot the bending moment diagram. The ordinate is WAB by L. All of us know WAB by L. W is 10, A is 1, B is 2 divided by 3. That comes out to be 6.67 kilonewton meters. Can I plot the bending moment diagram for these? Yes, the bending moment diagram will be like this. Eccentric on this side, eccentric on this side, and again this is WAB by L. 15 into 2 into 1 divided by 3. So this comes out to be 10 kilonewton meter. If you calculate, it is 10 kilonewton meter. Now my friends, for both BC is right hand span. You see, AB is left hand span, BC is right hand span. So for right hand span, I need to calculate x3 bar. I need to calculate x3 bar for both the figures. I need to calculate x3 bar for both the figures. X3 bar is the distance of the centroid. I say this is centroid. I say this is centroid of the triangle. Distance of the centroid from right hand support. Now from right hand support, it will be 3 plus 2 divided by 3, that is equal to 1.67 meter. From this support, it is 3 plus 1 divided by 3, that is 1.33 meters. I hope you got the idea. From the right hand span, for this triangle, it is eccentric on this side. So the distance will be 1.67 meters. For this triangle, this is eccentric on the right hand side. So the distance from the right hand side will be 1.33 meter. So x3 bar for, let us say this diagram is A. Let us say this diagram is B. x3 bar 3A is equal to 1.67 meters. x3 bar 3B is equal to 1.33 meters. Both the triangles will have different x3 bar. Now what about the area of the triangle? Yes, area of the triangle I know A3A is equal to, for first figure, half into base into 6.67, and A3B is equal to half into 3 into 10. So this comes out to be 6.67 into 3. I take it at 20. I take it as 20. 20 divided by 2, that is 10. And A3B, A3A, these two figures, A3B is half 10 into 3, 30. 30 divided by 2, that is 15. So this I have calculated for BC portion by principle of superposition. I have divided the structure into two parts by each load acting on one part, and then I have calculated the bending moment diagram under the load. Can I calculate the bending moment diagram under these two loads? Yes, I can calculate. The diagram will be a trapezoid. A diagram will be a trapezoid. I know the diagram will be a trapezoid, but it is very difficult to determine the center of gravity of the trapezoid. Area is simple, but centroid of the trapezoid determination is somewhat complex. You need to remember complex formula, and I don't want you to remember the complex formula. So we'll divide the structure into two parts. Don't have this approach. Many books have given this approach. Don't have this approach. Divide it into two parts. One is this triangle, other is this triangle, right? If there is one UDL and one point load, then this figure is complex. This is neither a pure parabola, this is neither a pure triangle. So it is always better to distribute the structure into which is acting by two loads into acting by two different loads, and then addition of individual effects will give you the principle of superposition, will give you the proper idea regarding this. So this is I have calculated A3 bar and X3 bar for portion A, A3 and X3 bar for portion B. So we have seen how to take into account the effect of principle of superposition, and I have taken the effect of principle of superposition by taking the bending moment diagrams for the portion BC. Now for the portion AB, this is 20 kilonewtons, sorry, for the portion AB, I am cancelling this. For the portion AB, it is 20 kilonewtons acting on the right hand side, 20 kilonewtons acting on the right hand side at a distance 2 meter from B and 1 meter from A. This is acting on the right hand side. I know the bending moment diagram, very simple. The bending moment diagram will be eccentric like this. It will be 20 into 2 into 1 divided by 3. So that is equal to 13.33 kilonewton meter. Simply supported bending moment diagram, and position of centroid from the left hand support, because AB is a left hand span. So position of centroid from the left hand support in this bending moment diagram will be this is centroid. So position of centroid from left hand support, 3 plus 2 divided by 3, that is equal to 1.67 meters. So this CD is 1.67 meter from left hand support. So X3 bar, that is X1 bar. Now there is a single force, so only X1 bar. And what is A1? A1 will be equal to half into base into height, 13.33. I take 13.33 into 3, that is 40. 40 divided by 2, I take 20. A1 equal to 20. So A1 X1 bar, whereas here we got A3 X3 bars. Here we got A3 X3 bars for A portion, for B portion, A1 X1 bar. So all our ground work is ready. Now applying, now what is M1? M1 is MA, because we are applying it to the position of ground work. Now let's come back to our original structure, applying three moment equation to spans AB and BC. So M1 is MA, M2 is MB, the middle moment is B, and the third moment is MC. I am applying to AB and BC. M1 is MA, M2 is MB. What is L1? L1, that is length AB, is 3 meters. What is L3? L3 is again 3 meters. What is I1? I1 is equal to I. I am not going to put the value of I till the final step. I will not increase my calculations. In the final step, what is I3? I3 is 2I. Right, my friends, I am applying, I know A1 X1 bar, A3 X3 bar, I am applying the three moment equation, but there is settlement of support. So I am applying three moment equation, that is MA into X1 upon L1 upon I1, that is 3 upon I, plus twice MB, M2 into L1 upon I1 plus L3 upon I3, that is 3 upon I, plus 3 upon 2I, plus M3, that is MC, into 3 upon 2I is equal to, this is left hand side, is equal to minus 6. What is A1? A1 I know, already calculated A1 is 20. So minus 6 into 20 into X1 bar. x1 bar I know 1.67 meter distance from the left hand support. So it will minus 6 into 20 into a1 x1 bar upon I1 L1 3 into I minus 6 into. Now my friends, a3 into x3 bar we have to take into combination. a3 into x3 bar, look at this, minus 6 into, I am taking the first a3, 10 into x3a bar 1.67 plus I am taking the second AC 15 into x3 bar 1.33. I hope you have understood this. Instead of calculating it area of a trapezoid and then remembering the formula for centroid, remember the principle of superposition. We have distributed this into two parts. A1 will be different, x3 bar will be different, a3 will be different, x3 bar will be different. So multiplying this a1 with x3 bar of this particular plus multiplying this multiplying this a3 with x3 bar of this figure and multiplying this a3 with x3 bar of this figure, and then addition of these effect will give me the total effect given by the two supports acting simultaneously. This is nothing but principle of superposition divided by 3 into 2i. 3 into 2i plus supports are settling 6e h1 upon L1 is 3 plus 6e h3 divided by L3, that is 3. Now my friends, what we will consider how this h1 and h3 are to be taken into consideration by taking original structure. Now look at this. Original structure says support B settles down by 5 mm, support C settles down by 12 mm. I am applying it to the portion AB and BC. Support B settles down by 5 mm. So this is 5 mm. Support B settles down by 5 mm and support C settles down by 12 mm. So this is 12 mm. This is support C. Which is settling down by 12 mm. Now what is H1? We have seen H1 is relative position of left hand support with respect to central support. Left hand support is 5 mm up by central support. 5 mm up by central support. Left hand support is 5 mm up by central support. So H1 is equal to 5 plus 5 into 10 to the power minus 3, because we are calculating everything in meter, so I need to convert this into meters. H1 is 5 into 10 to the power minus 3. Now what is H3? I will again repeat that H3 is the relative position of right hand support with respect to central support. At present we are applying it to AB and BC. So C, that is 7 mm, right hand support is 7 mm down by central support. Everybody agree? Right hand support is 7 mm down by central support, and that is why H3 is equal to minus 7 into 10 to the power minus 3 meters. So these are the values of H1 and H3. These are the values of H1 and H3. Now my friends, I will convert this equation. This equation is there. I have already calculated the value of H1 and H3. H1 is 5 into 10 to the power minus 3 meters. H1 is minus 7 into 10 to the power minus 3 meters. Why minus? Because in this case, the right hand support is 7 mm down of central support. Down means negative, up means positive. In this case, left hand support is 5 mm up of central support. So up is positive, down is negative. So we have converted this. Now my friends, look at this equation. I will multiply this equation by I. Multiply this equation by I. I will multiply the whole equation by I. Now pay attention, what will happen if I multiply this equation by I? What will happen if I multiply this equation by I? This term MA into 3I, 3 upon I into I will be 3 MA plus, if I multiply this with I will get cancelled. 3 upon 3 by 3 plus 3 by 2, 3 by 2 is 1.5, 3 plus 1.5 that is 4.5 into 2 that is 9 MB plus, if I multiply this with I will get cancelled. 3 by 2 is 1.5 mc. 1.5 mc is equal to, this I will calculate later, this I will calculate, or I will calculate. This I have already calculated. This I have already calculated. This comes out to be, this term comes out to be minus 66.8. This I have already calculated. This term comes out to be minus 36.65. This I have already calculated. Now look at these terms. Now look at these terms. Plus 6ei. 6ei. Now I will multiply this with I. 6ei into h1 divided by 3 plus 6ei into h3 divided by 3. I have multiplied this with I, so I of these terms will get cancelled. Okay, I will get pure values of these two terms which I have written, minus 66.8 minus 36.5 plus 6e into I, h1 plus 6e into I. Now my friends, I have already known the value of e and I. Let us calculate it rough. Let us calculate the values of e and I rough. Okay, this is my equation, 6ei, h1 and h3. What is the value of e and what is the value of I? E I know. What is the value of E? E is 2 into 10 to the power 5 Newton per mm square. This is the value of E. I need to convert everything in kilonewton and meters because everything was given in kilonewton meters. If I want to convert this Newton into kilonewton, I need to multiply it 10 raised to minus 3. If I want to convert the Newton into kilonewton, I need to multiply with 10 raised to minus 3. And if I want to convert this 10 mm square into meter square, I need to convert 1 mm square is equal to 10 raised to the power minus 6. This is kilonewton and this is meter square. 1 mm square is equal to 10 raised to the power minus 6 meter square. Since 1 mm is equal to 10 to the power minus 3 meter, therefore 1 mm square is equal to 10 to the power minus 6 meter square. So 1 mm is equal to, so that's why 10 to the power minus 6 meter square. If I bring it in the numerator, it is 2 into 10 to the power 3 into 10 to the power, 2 into 10 to the power 5 is given value. 2 into 10 to the power 5 is the given value into 10 to the power minus 3 into this minus will become plus in the numerator. So I am getting the value of this as 200 into 10 to the power 6 kilonewton meter square. This is the value of E. This is the value of E, 200 into 10 to the power 5 kilonewton per meter square. Now consider the cross section. How is the cross section? The given cross section is 10 centimeter by 15 centimeter. So I is equal to, now it is 10 centimeter by 15 centimeter, 10 centimeter width and 15 centimeter breadth. So that is 100 mm width and 150 mm depth. So this is rectangular cross section. BD cube by 12. BD cube by 12 is the moment of inertia, that is 100 into 150 cube divided by 12. So I have calculated that already. That is equal to 1230 mm to the power 4. Now since 1 mm is equal to 10 to the power minus 3 meters, therefore 1 mm to the power 4 is equal to 10 to the power minus 12 meter to the power 4. We want everything in meter to the power 4. So that comes out to be 1.25 into 10 to the power minus 6 meter to the power 4. This is the value of I. This is the value of E in kilonewton meter. This is the value of I in meter to the power 4 kilonewton per meter square, right? Kilonewton per meter square E. Therefore, value of EI, if I multiply this value of EI, it comes out to be 250 kilonewton meter square. It comes out, this 1.25 in 10 to the power minus 6 and 200 in 10 to the power 6 minus 6 plus 6 will get cancelled. 1.25 into 200, that is 250 kilonewton meter square. This I have calculated in kilonewton meter square. Remember friends, examiners will try to confuse you by giving the units, various units, one in mm, one in centimeter, and all structure is in meters. We are dealing with kilonewton meter square. So value of EI we got 250 kilonewton meter square. Now I am going to put the value of EI and value of H1 H3. Value of H1 H3 I have got. H1 was 5 into 10 to the power minus 3. H3 is minus 7 into 10 to the power minus 3, and EI is 250. I have shown you how to calculate the value. So I am going to put the value 3 MA plus 9 MB plus 1.5 MC is equal to minus 66.8 minus 36.65 plus 6 into EI. Just now I have calculated a value of EI. EI is equal to 250 into H1. H1 I have calculated. H1 is 5 into 10 to the power minus 3. 5 into 10 to the power minus 3 divided by L1, that is 3, plus this 6 next, plus this 6 into EI is 250, I know. But what about H3? H3 is minus 7 into 10 to the power minus 3. H3 was negative, divided by 3. So I can just cancel this and I can write the value of minus. Minus I will take out of the bracket. I will take the value of minus. And by calculating this, I am getting the equation 3 MA plus 9 MB plus 3 MC is equal to minus 104.45. Now my friends, again this is the most complicated numerical. What is the value of MC? What is the boundary condition? What is the value of MC? Yes, have we calculated it? Yes, in the first step, that is for drawing equivalent structure, we have drawn the equivalent structure. And have we found out the value of MC? We have drawn the equivalent structure and we have found out the value of MC. Look at this. Look at this structure. The first step, we have drawn the equivalent structure. What is the moment at C? What is the moment at C? We have just shown it on the structure. We have drawn the equivalent structure like this. We have drawn the equivalent structure like this. Yes. Look at this. This is the second portion of it. We have drawn the equivalent structure like this. What is the value of MC? MC is 4.5. Value of MC is 4.5. This is the equivalent structure. But is it sagging or hogging at C? Is it sagging or hogging at C? If this is the support, I will show you. If this is the support, if this is, let us say this is beam C, and I am applying the force like this. I am applying the force like this. It will create tension on the top fiber. It will create tension on the top fiber. So it is hogging. If I am applying clockwise, if I am applying anti-clockwise, it will create tension at the bottom. So it is sagging. So this means I can take the value of MC, since value of MC in the equivalent structure, value of MC is minus 4.5. Why minus? Because this is the hogging moment. That is why it is minus 4.5. I will replace MC in this particular equation. I am getting equation 3 MA plus 9 MB is equal to, I am getting an equation in terms of MA and MB is equal to minus 90.95. This is my first equation in MA and MB. This is my first equation with two unknowns, MA and MB. So friends, I got the first equation by applying the three moment equation to the spans AB and BC. I have applied AB and BC. Now I don't have any span left to apply the three moment equation, but I know I can take an imaginary span beyond AOA, so that I can apply the three moment equation to the span AOA and AB, and I can doing it. So I will proceed. I got the first equation. So I am getting the second equation. Consider an imaginary span. Consider an imaginary span AOA. Now imaginary span should be considered beyond the fixed support AOA, such that length of AOA is equal to LO and I of AOA is equal to infinity. Length of AOA is equal to LO and I of AOA is equal to infinity. I am drawing AOA. This is A fixed support and AB, which is loaded with a 20 kilonewton load acting at 2 meters and acting at 1 meter. This is A. this is B, and this is AO. The length of AOA is any length LO, and I is equal to infinity. Here I is equal to I. I is equal to I is equal to infinity. Now applying three moment equation to these two spans, applying three moment equation to spans AOA and AB. What is M1? The first moment will be MAO. What is M2? Second moment will be MA. What is M3? The third moment will be MB. What is L1? LO. What is L3? L3 will be 3 meters. What is I1? Infinity. What is I3? It will be I. Now I know the bending moment diagram for AB. Left hand side there is no bending moment. AOA, there is no simply supported bending moment, but for right hand side there is simply supported bending moment like this. This is right hand side, this simply supported bending moment is 13.33 kilonewton meter. This is of the length 3 meters. And now what is the distance of the centroid? The distance of the centroid from right hand support, because AB now is a right hand span. This is AOA and this is AB. AB is a right hand span. So distance of the centroid from right hand support, it is 3 plus 1 divided by 3, that is equal to 1.33 meters. Distance of the centroid of AB from right hand support, see, this is 3 plus 1 divided by 3. So that is equal to 1.33 meter. So I can write the three moment equation. Everything is ready with me. For this, there is no bending moment diagram. I can write the three moment equation. First moment MAO into L1 upon I1 infinity, right? Plus second moment MA. The second moment is MA. M2 is MA into L1 upon I1 plus L3 upon I3, 3 upon I, plus the third moment MB into 3 upon I is equal to minus 6 into A1 x1 bar into L1 I1. I will not bother about A1 x1 bar because the denominator is infinity. Minus 6 into A3. I know what is A3. A3 was 20. I know, I have calculated A3 was 20 into x3 bar 1.33. In the previous example we have calculated x1 bar because AB was left hand span. So x1 bar was 1.67. In this example we will calculate x3 bar because AB is right hand span. I need to calculate distance of the centroid from the right hand span into 3 into I, right? 3 into I. Now that is not over. Plus 6E H1 upon L1 plus 6E H3 upon L3. L3 is 3 meters. 6E H3 upon L3. Now my friends, which support is settling down in AOA and AB? AOA and AB. Support B has settled down by 5 mm. Support B has settled down by 5 mm. Now I will calculate the value of H1 and H3. What is H1? H1 is relative position of left hand support with respect to central support. Now central support is A. What is the relative position of left hand support with respect to central support? H1 is 0 mm. Both the supports are at same level. H1 is 0 mm. And what is H3? H3 is relative position of right hand support with respect to central support. Central support is A and the right hand support B has gone down by 5 mm. So H3 is minus 5 into 10 to the power minus 3 meters. I hope it is understood. H1 is the relative position of left hand support with respect to central support. H3 is the relative position of right hand support with respect to central support. Support B is settling down by 5 mm. So AOA, they are at same level, so it is 0 mm. H1 is 0 and H3 is support B is settling 5 mm down. So with respect to central support, support B is 5 mm down, and that is why H3 is minus 5 into 10 to the power minus 3 meters. Why minus? Because relative position is down. If the relative position is up, it is positive. If the relative position is down, it is negative. So H3 is minus 5 into 10 to the power minus 3. So naturally H1, if I put it in this particular thing, it will be 0. this term will be 0, this term will be 0, and I am multiplying everything with I. I am multiplying this equation with I. So I am multiplying this equation with I and I am putting the value, okay, I am putting the value, multiplying this equation, this term will be 0 because it is divided by infinity, this will be 0. If I multiply with I, it will be 3 into 2, that is 6 MA. If I multiply this with I, then plus 3 MB, 6 MA plus 3 MB. I have calculated this minus 6 A1x1 upon I1N1 plus minus 6 A3x3 upon I3L3. This will be 0. I have calculated this. This is minus 53.2. This is 0 because H1 is 0. This term is 0. So this is 0. And now I am putting this plus 6 EI into H3 minus 5 into 10 to the power minus 3 upon L, that is 3. I am putting the value of EI minus 53.2 plus 6 into EI value is 250 into minus 5 into 10 to the power minus 3 divided by 3. So that comes out to be minus 53.2 minus 2.5. This comes out to be 2.5 minus 2.5. So that comes out to be minus 55.76 MA plus 3 MB is equal to minus 55.7. This is my equation number 2. My first equation I have already got. My first equation is in MAMB. 3 MA plus 9 MB is equal to minus 90.95. This is my second equation. 6 MA plus 3 MB is equal to minus 55.7. Therefore, I can write MA is equal to, I can solve these two equations with two unknown, minus 5.07 kilonewton meter, and MB is equal to minus 8.41. Both the moments are negative. We know how to show these negative moments on the original structure. So I am drawing the original structure once again. This is support A. I am drawing the full structure now. This is B, this is C, and this is D. So I am drawing the full structure. I am representing the moment. MA is minus 5.07. This means it must be hogging. So I am showing the hogging moment minus 5.07 kilonewton meter. Friends, remember, is it hogging? Let's look at it. This is fixed. I am going to rotate it like this. I am going to rotate it in an anti-clockwise direction. So it will hog, it will have this shape. Again, for MB portion, 8.41 hogging. This means for both the portion I am showing 8.41 kilonewton meter hogging. Look at this. MB, if it is hogging, I am applying a clockwise moment. I am applying a clockwise moment. It is showing tension upwards. For a BC portion, if it is hogging, I am applying a clockwise moment. The tension is upwards, so it is hogging moment. Now, do I know the value of MC? Yes, I know the value of MC. I know the value of MC in my equivalent structure. I have calculated this as 4.5. So this is 4.5 and 4.5. So 4.5 kilonewton meter hogging in both the portion. I am drawing the full structure now. I am drawing the full structure in both the portion. I am showing the loads. This is 20 kilonewtons. This is 10 kilonewtons. This is 15 kilonewtons. And the remaining portion is, I think, 4 kilonewton per meter for remaining distance. 4 kilonewton per meter for remaining distance. So this is how I have represented this particular moments, obtained moments on the given structure. 1 meter, 1 meter, 1 meter, 1.5 meters, and this is 2 meter and 1 meter. This is how I have represented these moments, obtained moments MA and MB on my given structure, and I can plot the bending moment diagram of it, which we will discuss in our next lecture.